circle arcs and angles. Okay, we have angles from our circles defined by our radius or our center position, and we have arcs of a circle which are portions of the entire circumference. So let's take a look at central angle and arc. A portion of the circumference of the circle is defined by the angle. If you take a look in our example, we have an angle of 100 degrees, and the arc we're talking about is arc DF. The degree measure of the angle of the intercepted arc equals the center angle. So if we wanted to define the length of arc DF in terms of angles, we would simply say that because arc DF is made by an angle of 100 degrees, arc DF has a length of 100 degrees. So we can measure the arc in terms of degrees, and we know that it's equal to the center angle that creates that arc. Now we have an inscribed angle and arc. An angle with its center at the endpoints of the arc on the circumference of the circle. The angle of the intercepted arc equals twice the inscribed angle. Now take a look at this angle. Our arc that we're talking about is arc PR, but rather than arc PR being created by an angle that starts at the center of a circle, it's created by an angle that started all the way on the other side of the circle. So in this case, if angle Q has a degree measure of 55 degrees, length P or arc PR does not have a length of 55 degrees like it did for our arc that was created by a center angle, but now rather the length of arc PR is double the angle measure of angle Q. So if angle Q is 55 degrees, then we say the degree measure of arc PR is double that, or 110 degrees. So again, an arc is simply a portion of a circle. We can create it two ways. We can create it from an angle at the center of a circle, or we can create it from an angle on the far side of the circle. We create it from a center angle. Whatever that angle measure is, that's how long the arc is. If we create it all the way from the other side of the angle, we have double that angle measure to figure out how long the arc is. Okay, now thirdly, what if we want to actually solve for the length of the arc, not in terms of degrees, but in terms of meters or centimeters or inches or whatever unit of measurement we're talking about. To find the numerical length of an arc, find the circumference, then multiply it by the fraction of its angle relative to the entire circle. So that would be angle divided by 360 degrees. So in our example, the length of arc AC is simply the entire circumference, 2 pi r, times this ratio or this percentage of what angle x is to the entire circle, which is 360 degrees. So to find the actual numerical length of our arc AC, all we need to know are the radius of the circle and the value of angle x, how big of an angle we actually are talking about. Finally, we have a sector. A sector is a portion of the area of a circle formed by an arc. So now, rather than just talking about the distance around the circle, we're talking about the entire area of that piece of pie. To determine the area of a sector, it's very similar to finding the length of the arc. Find the area of the entire circle, then multiply by the fraction of the arc angle to the entire circle. So when we were talking about finding the length of the arc, we found the entire circumference and then multiplied it by the percentage of our angle. Now we're talking about the area of our piece of pie, so we want to find the entire area and then simply again multiply it by the fraction of this angle. So the area of sector ABC is equal to the entire area of the circle, pi r squared, multiplied by, again, our percentage of this angle, or our fraction of this angle x divided by the entire angle measure of the circle, 360 degrees.